So this is the chapter 4, reasoning and design. And so we are in the middle of the book. I will cover the first section, control issues in design. So as you remember that control was related with reasoning and also meta-knowledge. First section is also divided into search strategy. So reasoning is related with controlling and also related with searching. Okay. So simply, they want to find this is a design space. Design space. There are so many options of alternative designs. Alternative designs. Right? Among them, I want to find out the best one. That is search strategy. I guess who already take optimization class? Only one. Right? Optimization is also similar. I'm searching for, say, minimum point on, say, simply when you're traveling along the country yard, the lowest point there should be water. Right? So how can you reach to the lowest point within the region? Within the region. So we call this as a minimization. Or sometimes it's maximization. But anyway, so optimization is simply can be said as minimization. Finding out the minimum point in objective function space. Search. And goal satisfaction, we already see that goal decomposition. So goal should be satisfied. Here, the goal is to find out minimum point. Failure handling, sometimes there is a failure. In optimization, there is a constraint. You should not go into this region. There is a regulations. There should be the maximum stress should be below 10, something like that, or the dust in the air should be below 10 ppm, something like that. Right? Regulations. So that comes with a constraint. And violation of regulation can be a failure handling. And constraint again, right? Constraint again in optimization terminology. And non-monotonic reasoning. Non-monotonic means complex reasoning, not simple reasoning. And multiple knowledge resources. There are different types of knowledges. So how can you handle including multiple types of knowledge together when you're controlling, when you're manipulating, when you're reasoning? That kind of things are issues. Issues means some difficulties in reasoning. We'll see that. And design is trying to attempt to find the description, the drawing in the design space, the proper one, the best one, in design space that maps some intended performance, design requirement. Mapping. There is another space of requirement. So many requirements, right? I want to design a smartphone for Indian lady. I want to build my home in the countryside. and mapping between them. And we'll see that the next slide. It can be regarded as search inside a design space, producing a design that is progress in terms of progress, timeline, progression from an incomplete, unsolved, and possibly contradictory description of design. That can be a requirement description. Okay? Starting from incomplete, unsolved, and contradictory description of the design. I want to design a smartphone for Indian lady. That kind of incomplete, unsolved, probably contradictory, I don't know, and then find out the detailed, which can be manufactured, a design to a complete description, complete drawing that can be used for manufacturing. Selection among competing courses of actions. Actions can be an activity that is kind of controlling. So action is involved in controlling or search strategies. Action, movement and timeline, along the timeline. So this one is already C in chapter 1. Syntactic space and semantic space, where there is a performance or requirement in the interpretation. There's a requirement space. There's a syntactic space, descriptions, decisions. You should. If I want to go to the Busan, then you should take a left turn at this junction. There is an action or a decision. Goal satisfaction. Goal. You already see that. What is goal? Or in optimization terminology, they are saying objective. Goal. Interpretation of design and producing design. So we interpret of design whether the design satisfies the goal, and we produce design based on that goal to satisfy the goal. So that can be a starting point. Interpretation. Here, the book is talking about top-down strategy and bottom-up strategy. Right? So top-down strategy, they started from goal. So we call this is goal-directed search. You can remember the goal decomposition. We started from the goal, divide into smaller activities, sub-goals. So we start from the goal, top and down. And then, in other words, to prove whether the design possesses a certain set of properties. So, this one is only Korean. So whether this beam is breaking when I apply a force. So I want to design a beam which can support without breaking 100 kilogram force. Okay? So to prove whether the design possesses a certain set of properties. So this is similar to backward chaining. Start from the end point, and then backwards going to find out. So end point can be the goal state, right? And define it. Or maybe if you want to go to the Busan, you can plan using a map, starting from the Busan point, right? And then backward to the Daejeon. Right? That is another way to find out the best way. Right? The other one is starting from here. Right? That can be a forward chaining or bottom up. We call this is data-driven search. Or you can say the activity of finding out all you can about design. Right? based on given situation, given data set, right? All components, right? Lego blocks, there are so many elements here, hundreds of elements here. Using this data, you can do thousands of combinations, right? All combination I can do. There is a bottom-up start. But after that, you should select activities. But anyway, that kind of thing. Or starting from Daejeon area, you can do multiple directions. There are, on the map, they shows a street coming, starting from the Daejeon city. Probably, if I count a big road, that can be 5 or 6, right? So, starting from Daejeon, you can go on to 6 different ways to arrive at Busan. And after arriving another city, then that goes another 10 or 5 or 4 branches. Right? So, all you can do using Lego blocks. So, in combination, we need to do both ways together sometimes. For a complex system design, or software design, or chip design, or right? But simple design, simple item design, you don't need such a strategy. Simple. Producing designs, top-down goal decomposition. We already see that. How partial decisions made in response to individual sub-goals, right? So goal decomposition, there are sub-goals and sub-goals and sub-goals. Finally, there can be a leaf node, right? And then leaf node can be realized by combining, and then the sub-goals can be combined into the whole, produce the whole design. And this is start from what we want. That is a goal, right? Goal, and then objective, and then how to get it. That is or bottom-up configuration, right? Experimenting with elements in the vocabulary of design task and configuring them until we hit. Hit means without any intention. Right? They just use the combinatorial rules, right? Lego blocks. We don't know whether it can be a tank or it can be an airplane. Right? Just hitting, just configuring without any intention, any objectives. Right? So you can say generate and test. Generate means only grammatical rules satisfies. So for the chaining, we already see many times we start from fact and rules and then arrive at and conclusion. Or it can be a goal state here. Goal state. Arriving at Busan city. Arriving at developing a tank out of Lego blocks. But backward chaining, we start from the Busan and try to find out we can go on to the Daejeon city from the map. Okay. Questions? Failure handling. What we can do in the event of failure. So we are talking about in chapter reasoning in knowledge-based system. Sometimes reasoning can be a failure, similar to our human life. Right? And sometimes many people are doing backtracking to some earlier point and follow another line of reasoning. Right? So when we're traveling, sometimes we lost, right? And then what can be done? Some easiest point is return back up to whether you know where I am, right? You can find out on the map, right? And then decide to not this way again, right? Another way, take another way. That kind of thing is simpler. So you can use this kind of strategy in knowledge-based reasoning system or controlling. And also learning from failure is a very famous wording in my life too. So this shows backtracking. So when you hit some constraint there, failure there, or constraint, or barrier, find barrier, then you should return back to the earlier point and then try another strategy or branch of street or map. Constraint manipulation. That is related with optimization problem. Right? Constraint manipulation. So, feasible solution. Feasible. Distinction between constraint objective. Right? Objective and constraint. Objective is the goal, right? Goal state. Constraint, some regulation, barrier. So there is separation. And objective is a goal statement, and there should be a trade-off between conflicting objectives. There can be a conflicting objectives. Something like, say, I want to design a beam, big beam, with minimum weight, but also strong enough, right? Or minimum cost. That's sometimes going together, but sometimes it's conflict. In our life, same as this. So we need to have a trade-off. In optimization tool, there is we call this is a multi-objective optimization. Multi-objective problem optimization. Special word you can find in the literature. Multi-objective optimization problem. And then once again you need to have a trade-off between. But simplest way is you can convert one objective into another objective by using a simplification, and then make a single objective. That is the easiest way. But sometimes it's not easy. Provisional constraint, that is a tentative constraint that can later be relaxed in the event of failure. So we call this is a sensitivity analysis in optimization problem. Sensitivity. If I lower down the regulation for stress level by 10%, then what can be the optimal design changes? Right? So then we can find the most sensitive barrier, most sensitive constraint. And then we can study more, concentrate on study on by how to relaxing that constraint. So that kind of thing we can use for the sensitivity analysis. Non-monetary reasoning. Before it was provisional constraint. Very similar, provisional, but with also here is a temporary inconsistencies. Temporary, provisional constraint, or temporary inconsistencies in reasoning. Sometimes it is violating, but we can keep, because there are so many factors, variables. So we can keep this violation for the time being to search for another alternative. So they are saying search proceeds temporarily, including that failure. Right? Inconsistency means failure, violation. And then go on to backtrack. before going on backtrack. Right, this is just a typical game map, finding out treasure. Right? Treasure. Where is the treasure? Ah, here is treasure. Right? Treasure. Right. And starting from here. Yeah, starting from here. Right. So sometimes it's better to starting from the end point, right? And backward. But sometimes we lost in the middle. So you try starting from starting point and also search for some here. Or we need to have both backward and forward chaining together strategy. Right. And another issue, another difficulty in manipulation or reasoning is multiple knowledge resources. So in designing, human designers use and organize and obtain multiple knowledge resources. Right? Something like a text, code means the regulations, diagrams can be a drawing, and also you consult the human experts, experienced human, and then gathering all the knowledge from different resources. Then the problem comes with how to mix these different type of knowledge together. Humans can do, but computers can have a difficulty in handling such a different heterogeneous type of knowledge. Once you need to have how to find those knowledges first, and then what knowledge sources are there for that. So you need to find out. Nowadays it's much easier than before, right? Because of the Google and search engines, data mining, and then there are so many data around. But 20 years ago, 30 years ago, it is not easy to find out good data and knowledge resources. But now the problem is how to find out the good data or good strategy, good knowledge. That is more important than before. Because there's too much knowledge and too much data. Oh, that's good. Question. And we can go on to Hala. Hala will study it further.